Okay, okay. All right. So data availability is something that we think about, and it's gotten, I think, a whole lot better in the past few years, because it used to be that if you wanted to do insurance research, um, to do data analytics research, you need data, obviously. And it used to be that data was really, really hard to come by. No one was sharing any data, and data was hard to find. And today it's gotten better, but I think we would all agree that if we can make data more discoverable and accessible, and just having more of it, that's going to contribute to the progress of research. And it's not just academic research. It's also like if you wanted to build software or prototype workflows involving insurance analytics, it's always good to have more data. So let's talk about each of these issues or perspectives. So the first one is, there's data out there, and there's actually quite a bit of good, interesting data out there, but we might not always know where to find them, right? So this is a screenshot from I think this was the CAS website and the SOA website. So there's a good rich data, but if you're not familiar with the websites of various actual organizations, you might not ever come across them, or maybe you didn't read that one paper that cited this data set. You might not know about it. So there's a lot of places, again, where you can find these things. People have hosted packages and libraries that include data in them, and there's data sets from Kaggle competitions, which are also interesting, and then various organizations and companies also sometimes put things on their websites. So once you find the data, you'll have to figure out how to use them, and they typically come in a whole variety of different formats. You got CSV files, you got Excel files, you got data in Excel pivot tables that you have to do some hacking to extract, and there also APIs that you can hit nowadays. But then for the typical actual researcher, quite a bit of time is spent figuring out, okay, I got this data set. How do I actually get it into my analysis software of choice? And so this is an issue that that people come across, and then they we solve them. But then I feel like maybe we can reduce the repetition here. Maybe we can solve this issue for this data set just once or twice, rather than every time someone finds a data set that they have to go through the whole process. And lastly, of course, that there's still a lot of data out there that would be nice to have, but then due to privacy concerns, regulation, whatever, we can't get them. So then the question there becomes, how do we how do we make it so that we can get some of the content out there without messing with privacy issues? Okay, so I wanted to talk a little bit about a few of the open source projects that have come up in the past year or so, that try to advance data availability. So let's see. So a couple different perspectives tips on this that link back to the 3 points that we talked about. So first is if we can put these data sets that are available in different places in the wild in one place and document them, right? That's going to help with the discoverability aspect. And then to get more data into the knowledge base, we can also think about simulating data. And then there's different ways to do that. So we'll go through a couple examples. So the first project I want to call out is Cellar. So it's meant to be a community curated repository of data sets and tidy data sets. If you're familiar with the philosophy of the tidyverse, and it's an R package and also a website where you can look at the different data sets. And if you actually look at the implementation, it's actually pretty easy to come up with a Python and also a JavaScript API to access all this data. So if you're interested, we can definitely talk. But the documentation consists of a data dictionary and also some summary stats. So the idea is that you're a researcher or a developer. You go on this website and then you take a quick peek at what's in a table, and then if it's relevant to you, right? Then you can easily and quickly get that data onto your desktop or laptop or whatever, and start playing around with it. Okay, so I do have a couple more projects I want to go over. So if you feel like it, you can just go on the website right now. It's cellar.kasa.ai, and just to get a feel of what that's like. Okay, so we're gonna move on to simulating data, and there's a few projects that's been I find to be pretty interesting. So the first, this one actually came up probably maybe 2 or 3 years ago. So this is work by the folks at ETH Risk Lab, and it's an R package that allows you to simulate individual claims data. So, and why is this relevant? So, if you are into loss reserving, right? And if you're into triangles, actually, let's take a step back. Let's talk about just individual claims. If you're into individual claims reserving, which is sort of a hot topic these days, in the Schedule P and whatnot, you only have the aggregate triangle data, but then this package allows you to generate individual claims data. And if you just wanted triangles, then of course you can aggregate this data into triangles. And the way that I need to remember how many slides I got here. So the way that they sort of did this is they thought about the different processes that sort of model the life cycle of a claim, and then for each of those processes, they model it with a neural network, and it's actually so a bunch of neural nets that are calibrated to a real insurer's experience, right? So then this package comes with it's basically a pre-trained neural network that was calibrated to some real data. So it's going to spit out data that's somewhat realistic. And then there's a few configurable parameters that a user can specify. So again, the idea is that you go download this package and then you can start playing with it. Okay, so yep. And then more recently, the folks at UNSW and the University of Melbourne put together another simulator. And where did my slide go? So it takes a little different of an approach. So again, this is also for it's also meant for loss reserving and claims analytics. And the way that they did this, I'm going to try not to lie here. It's been a while since I looked at the paper, but they look at it from a grown-up approach. So again, each process that contribute to the life cycle of a claim is a model. I don't think that they use neural nets is actually these stochastic processes. And then again, that the user has a lot of flexibility as to what each process looks like. So then once you specify all of these, and again, there's infinitely many permutations that you can customize it. You get this again transactional level data sets that that you can use to do either individual claims analysis or aggregate it into triangles. And I believe at the time of this release, it was just paid losses. But then I spoke with Greg Taylor a while back, and I think that there's actually incurred losses that the reported amounts that they've baked into it. So if you're a researcher or you're interested in loss reserving, this is another project to check out. Okay, so next up is a CT-GAM package, and this is moving away from loss reserving. This is more for your vanilla tabular predictive modeling data sets, and it was actually introduced by machine learning researchers in a NeurIPS paper, I think a couple years back. So they provided a Python package, Python library to generate data, and then we then provided an R wrapper on top of that to make the features available to a bigger group of researchers. So the idea here, and then we'll spend a little more time on this because I'm a little more familiar with it, is we use what's called generative adversarial networks to learn how to come up with data sets that are realistic. And again, there's a package, so the idea is like for you to just like download it and give a shot, get a feel of what it's like, how it behaves, and then you can then check out the paper, the blog post, and see what's under the hood. But at a pretty high level, this is sort of how it works. So we want to take a data set, and again, a tabular data set with categorical columns and also numeric columns. And the goal is to come up with a workflow that allows us to generate rows of a table that look a lot like the rows of the actual table. And so these are a couple different pictures that illustrate the same thing. And I'll try to talk through this. We'll see how I do. So basically, we look at the actual data set, and then we pick a column. We pick a categorical column, and I think it might make sense to just like think of an example. Let's say we're doing auto, severity prediction, right? So each row in this data set that we're playing with may be a policy, right? And then each column will be a policyholder characteristic. So perhaps we look at the color of the car, right? That may be one of the columns. And then we randomly sample a category, say red. Okay, so then we're going to find a row in this data set that's a red car, and then that's going to be our sampled real data row. Okay, so what we're gonna do is we are going to encode this condition, this red car that we randomly pick. We encode it as a condition, and then we add some noise to it, and then feed it to a generator function. So here the G here is a function. It represents the process that sort of creates or simulates the data, and then C here is the critic or the discriminator, and its goal is to determine, given a real row in the data and a fake row in the data, which one is real, which one is fake. So basically, the generator will come up with a fake row of data. So it could be like, okay, so it's a red car, policy holder age, 25 to 30, lives in this area, has had 2 accidents before, right? And then the real data row might be the red car. Again, the policyholder is 18 to 25, and then and so on. And then this critic is going to determine or try to determine which one is real, which one is fake. So both of these functions are parameterized by deep neural nets. And the idea is that you go through this training process, and then the critic gets graded how good it's good at how good it is at determining which record is real and which one is fake. And then the generator gets graded on how good it tricks the critic, if that makes sense, right? So it's almost like the analogy I like, because I'm into wine, is like the generator is someone who's mixing cheaper Napa Valley Cabernets and then trying to pass it off as like first growth Bordeaux, and then the critic is like the expert that tries to taste the different wine and then say, okay, this one's real, this one's fake, right? So so this is like a really high level what a generative adversarial network works when we try to apply it to tabular data generation. Okay, so like that's some technical nonsense. You're probably thinking, okay, well, how will this the thing work. And there's like different ways we can evaluate how good a data simulator is, and then it also depends on what the use case is. So the couple of ways that we looked at that we sort of evaluated how well the thing perform is, one, we look at the distribution of the columns, right? So that's a pretty straightforward way to think about it. If our real data set has 20% red cars, but our fake data set has 100% red cars, it's probably not doing a great job. And then the second one is how, like, this is a little tricky, but basically for if you compare a model that's trained on the synthesized data set and then compare its predictive performance to a model trained on the real data set, like what's the discrepancy? So we'll take a look at both of these concerns. Okay, so I think many of us would be familiar with the TPL datasets in the CAS dataset package. Unfortunately named because it's the book CAS. Michael, do you know what you know the book I'm talking about?
I actually don't.
Is a computational actuarial science. I think Arthur Charpentier is the other.
Yes.
Okay, so that's CAS anyway. So this is a data set from that that book, and then it's a it's an auto pricing data set, and then these are a couple of the variables, and you can see that at least for these variables, the distribution of these categorical variables tend to be somewhat similar. And then going back to the machine learning efficacy, what we did here, okay, it's slightly involved, but it's basically just cross validation. So let's walk through this real quick. So we have a data set. We're going to cut it into 10 equally approximately equal subsets, and then what we're going to do is we take 9 out of 10 of these, and then call it our analysis table. So with this, we first feed it through our network to learn a generator, right? So going through that little diagram that we showed to train this generator that's going to spit out fake data set rows, and then this generator is going to come up with a table that's completely made up, right? So our T sub analysis super K, this is our real data set, and then this is our fake data set on the right. And then we're going to create a model, a GOM in this case, based off of these two data sets, and come up with two models. So we got a model that's trained on real data, and a model that's trained on fake data. And then recall that we still had 1 out of 10 slices of the data set left, and then we're going to use that. We're going to score that data set and then compare the performance of each of these models, right? So you got a model trained on fake data set and a model trained on real data set, And then the idea is that, okay, if your data simulator is any good, the performance should not be like too much worse, right? Okay, so this is not that many data points to look at, but at least we can see that did I not label my, okay, I can see if I, okay, I'm not gonna try to move this Zoom thing because I might break it. But I think these were actually RMSEs, probably. That's what, that's probably a reasonable metric to look at. And then the bar plot is, I mean, the box plot is basically the RMSEs over the 10 different model performance what is it, numbers that come out of the tenfold cross validation. So we see that the synthetic data sets didn't do too much worse. And as actuaries, we like to use GOMs, and then when we have a GOM, we like to look at the relativities of our model, and this is where this synthesizer I feel like wasn't doing too well, because like ideally if ideally the relativity is coming from the GOMs trained on synthetic and real data should be somewhat similar, right? But in this particular case, that wasn't that didn't materialize. And then we didn't do too much hyperparameter tuning on the network, so maybe we can get it to work with some effort, but maybe not, right? And this is good and bad because talking to some folks in the industry, that sometimes they're like, okay, we can share a realistic looking data sets, but we don't want other people to be able to come up with our proprietary models, right? And then so then it goes back to, okay, what's your use case? What are you bringing to share? And then that all of those factors determine whether this specific tool is fit for purpose in your use case. Okay, so overall, I think that the main idea that I wanted to convey is that there's this problem that we're trying to solve, is which is realistic data sets are hard to come by, and then the solution that we sort of encourage people to contribute to is one, make it easier for people to find these data sets, and then two, get more data sets out there. So if you're interested in helping out with any of these, or to share data sets, or do some software engineering, or any advice, comments, questions, please send them my way. I'll leave with a few resources. So don't think I mentioned this, but Kasa AI is basically this online community / blog that I maintain, and the idea is to get folks together to contribute to open source in insurance and analytics. And this we're not fixated on this particular community. There's a lot of others out there that do the same thing, but I would just encourage you to like contribute to open source, whenever and wherever. And then I also want to show this working party that's sponsored by the IFOA, because I noticed that a lot of people here seem to be interested in last reserving. So this working party is looking at ways of applying machine learning to reserving, and there's quite a bit of educational content and tutorials in R and whatnot that you might find interesting. And one of my New Year resolutions is to be a little more active on Twitter and sharing the new results. So if you're on there, follow and give me a shout. Okay, so hopefully we have time for a question or two.